Good evening. I'm here to talk to you about how to build web systems that are secured with Auth 2 and OpenID Connect. So, what is this all about? The abbreviation Auth actually means two different things. On the one hand, it can mean authorization, which is what Auth 2 does. So, authorization is giving an app or something the ability to do something. So on your phone, it would be like using a phone app that needs access to the camera and granting that app the access to the camera. In the physical world, it would be a bit like getting a wristband when you attend a conference. It doesn't matter who you are, the wristband is the thing that gives you access. Authentication, on the other hand, answers a different question. It answers the question, who are you? And that's what OpenID Connect is all about. So typical examples is when you log into a service like GitHub or codebar, and in the physical world, that would be equivalent to having a passport. The passport specifies to the readers, identifies who you are, but it doesn't tell them what you're allowed to do. And you've got some documents in the real world that combine both information. So your driving license, for instance, specifies who you are on one side and what vehicles you're allowed to drive on the other side. So, design, making that work on the web. How does that typically work? If you consider that you've got a service with what you call a protected resource, so for example, a confidential document that you want to give access to, that you want to have access to, and you're going to access this service via a client application, so typically your web browser. One of the first ways to do this would be to share the credentials with the client and have the client replay those credentials to the protected resource. But as soon as you copy your credentials around, you may lose them, you may share them with someone you didn't mean to, someone may steal them. So that's not ideal. The next option, which is quite often implemented on the web, is to ask for the credentials when you need them. So the client app will say, oh, you need to log into to your online banking, I need your password. But the question is, how often do you ask for those credentials? You don't want to ask every time you need to request something. So typically you have to store them somewhere and have some session management in play to keep them there, to keep the credentials valid until you log out. That's not ideal. Another way to do this would be to give the client a universal key that gives it access to everything. Now, the problem, as we know, is that it's always possible to have bugs in your client app. So if your app has access to more data than it needs to, you may have situations where you show one user data that they're not supposed to see. And a universal key opens that risk. So in practice, what you would really like to do is to have a token that is designed specifically to give you access to that particular resource at the time when you need it. But from a usability perspective, that's actually very complex to do right. So the solution you have on the web today, do this by using the mediation of an authorization server. And what happens is that if you go to your client and you're trying to access a protected resource, the client will request an authorization from the authorization server. You then grant the authorization by communicating directly with the authorization server and telling the authorization server, yes, I allow this app to access this protected resource. And the authorization server then gives the app an access token that the app can use to access the protected resource. So that's the overall design. One of the driving design behind this is the idea that you would have a lot more client apps than you would have protected resource or authorization servers. So the idea is to keep the implementation simple and the security requirements simple for the part that most people will build, i.e. the mobile apps, the web apps, and all that sort of things. The backend services, you'll have a bit less of them, but it still need to be reasonably simple to implement. The only security requirement is they need to validate the tokens you give them, but that's all there is. The authorization server, on the other hand, are where all the complexity and all the security lies, or most of the security lies. So that limits the surface of complexity and the surface of the security surface, which makes it easier to make it secure. What this also means is that in terms of upgrades, if you want the new fancy authorization mechanism, you just upgrade the authorization server. Client and protected resource should be able to benefit from that. So, with all this said, how do you implement this in practice? Right, Auth is an industry standard that allows you to implement this particular interaction between clients, protected resource, and authorization server. However, when you look at Auth, you will see in the spec that you've got 5 different flows, and basically an Auth flow is a way of interaction, so it looks quite complex. In practice, there is one flow that you really need to deal with when you do front-end work, which is the authorization code flow. That's the flow used for websites, single-page application, mobile apps. This is the key one to know. There's another one you may want to know, which is the client credentials one, which is used for machine-to-machine integration. So if your backend needs to have access to another resource that is protected by Auth, that's what you would use. The implicit password flows have been deprecated, so ignore them. The device client flow is designed for devices that do not have a web browser and possibly no UI at all. So that would be your IoT devices. So how does it work? Right. You go onto your fantastic app, and that app needs to access a protected resource. So at the point where it needs to access the protected resource, it will redirect your browser to the application, to the authorization server. And it will redirect you to the authorized endpoint in the authorization server. And it technically takes you out of the app. It's basically your browser is redirected. The app provides some basic information. So the scope is what the app wants to authorize. The client ID is a unique ID for this particular app. And the redirect URL is where the authorization server will need to redirect when it's finished. And that should be part of the allowed callback configured on the authorization server. So you're now interacting directly with the authorization server, and you can grant access to the app, to the resource that you need. So basically, you can give it, you can give the wristband is what you're doing at that point. And the authorization server next redirects back to the app and gives it a one-time code. And the app's not done yet. The app then has to resolve that code into an access token. So to do that, it calls the token endpoint in the authorization server. That's a post HTTP request, so either done by the backend or done as an AJAX call, and it gets an access token in return. With this access token, it can then go and access the resource that it wanted in the first place. Now, let's assume that this backend service, this resource needs to access another service to complete what it's doing. And at that point, we're in the realm of machine-to-machine integration. So we're going to use another flow, which is the client credentials flow, which is a simplified flow. And what it does is it goes directly to the token endpoint of the upstream authorization server, sends it the credentials as basic HTTP authorization, and gets a different access token back, and it can request the resource available on the other resource server. So that relies on the fact that your backend service is able to securely store access credentials for the other service. So that's basically the two flows that you will encounter most of the time with OAuth, and in particular the authorization code. So once you've done this, and assuming that you've wrapped all this into a single authorize method, which is typically what will happen if you use an off-the-shelf library, and most of them are great, use them, you're not quite done on the front-end side, because what this says is that you would need to authorize before you get the resource. So it doesn't mean you need to use the password every time you need a new resource. That's a bit complicated. We get into the usability problems we had earlier. However, the access token you get from Auth can be cached and reused. So in practice, in the front end, what you would do is first check, do you have the token? If yes, go to your resource server, get the resource. If no, then you can go through the whole authorize flow. The server may return with an HTTP 401 status code. Basically, the HTTP 401 is saying, hey, your token is not valid, I need a new one. At which point, you can get a new one by going through the authorization flow. So in practice, when your access token is valid, you can reuse it, but it may expire. Now, to avoid annoying your users too much, you probably want to have a fairly long expiry period. But on the other hand, the security people will tell you, no, we need a short expiry period. So how does Auth reconcile this? Auth reconciles the two conflicting requirements by also giving you a refresh token. So what the refresh token does is it allows you to just to refresh your access token if you can't get your resource by sending a post request directly to the token endpoint and getting with the refresh token and getting a new access token. So at that point, when you get to 401 after getting your resource, you can refresh your token, try to get your resource again. If you still don't get it, you can go through the authorize process, and that's your fallback. Always go through the authorize process. So now that we've talked about getting a wristband, how do you transform that wristband into a passport? So how do you authenticate people? That's where OpenID Connect comes into play. So practically, OpenID Connect uses the Auth flows. It doesn't change anything on this. The only thing it requires you to do is that as part of the scopes in the flow, you send it the OpenID scope. You can send optional scopes like email, profile if you want additional information. But once you send the OpenID scope, it knows that it has to go through the OpenID process, and therefore your authorization server will then act as what OpenID calls an identity provider, where it can do user ID and password, two-factor authentication. It can delegate to another identity provider if it wants to. So that's a situation where you've got your nice username and password form, but you can log in via Google or log in via GitHub. So it does all those things. OpenID Connect also defines a discovery endpoint. That's extremely useful because it means you can auto-configure the client and the resource server. So less configuration, that's good. And the last thing it provides is the user info endpoint. That's particularly useful for the protected resource because instead of having to understand the token you get, the access token you get, and decrypt it and all that sort of things, you can just call the user info endpoint with it and it will get the details of the user. Oh, and I forgot, OpenID Connect also provides you with an ID token. I won't talk about it because you don't need it for the default use cases. So, user info endpoint and the backend. What does the backend do when you got a user info endpoint? Simply what it means is that on the protected resource side, you can simplify the process. The only thing you've got to do is call the user info endpoint with it's a GET request with the correct token, with the access token. you might get a 401 HTTP result back, in which case you just forward it back to the application. It just means you need a new token. If you get the user info properly, you can check the claims. Well, claims is just a word that means that you get a JSON object back, and it's got a number of fields. Each field in it is a claim. And you will always get the subclaim. That's your subject. That's the unique ID for the user once it's been authenticated. You can also get an email claim, for instance, if you've asked for email, which might be a better way to uniquely identify your user. And the rest of it is dependent on your business logic. Do you need the user to be registered to provide your resource? If yes, check for that. Otherwise, provide the resource. Can you do on-the-fly registration? Then maybe do that. Otherwise, if you need to deny access to the resource, then you just reply with an HTTP 403 code. So these are the two HTTP codes you need to understand, you need to deal with on the back end, 401 and 403. Right, what next after that? That's a high-level overview of Auth and OpenID Connect. So next after that, just implement it in your project. If you've got a project where you would benefit from having a login scenario, just use OpenID Connect to do this. It sounds complicated, but once you've done it once, it makes a lot more sense. So find an OpenID Connect provider that you want to use. Google and GitHub are two good ones. One that I use in my projects is Auth0, because basically it allows you to build your custom OpenID Connect provider with delegation to other providers, and they've got a free tier. One point of note, Facebook is not an Auth2 or OpenID Connect provider. Their protocol is, if memory serves me well, is a bastardized version of Auth1. So it doesn't mean that it's the same concept, but don't use it if you want to understand Auth2 and OpenID Connect. Use something else. Resources, I suggest you have a look at auth.net, which has a lot of great resources on Auth2. Connect to ID has a great learn section that will tell you everything about OpenID Connect. And the provider docs are typically well written. If you really want to get into the nitty-gritty of it, you can get the Auth2 in Action book by Manning. It's extremely good. It will take you through all the different pieces to build an Auth2 authorization server, the protected resource, and the client. And it will also show you how OpenID Connect works. Other interesting protocols built on Auth2, you've got user managed access, UMA20, which is basically the logic you would have. When you want one person to be able to give access to a document to another person. So that's what happens on Google Docs, for instance, when you want to give someone access to a document, or when you want to request access from someone else. So that's the type of things that UMA20 does. IndieAuth is another type of authentication, different from OpenID Connect. It's got a few differences, and it relies on you having your own website, so it's not for everybody. And other concepts you may want to look into: the HTTP basic auth, which is used by Auth to interact with the token endpoint in particular. The Mozilla docs are great for that. JSON Web Tokens, you will not need them initially, but that's the format used for the ID token in OpenID Connect, so it's interesting to understand. Then OpenID is a wider spec than just OpenID Connect. There's other things there, so if you're interested, go and have a look. And SAML 2.0. SAML is an equivalent to OpenID Connect, but it uses XML instead of JSON. And you will find it in corporate environments, and in practice, it's a very similar behavior to OpenID Connect. So if you understand OpenID Connect, you will understand SAML. There's no problem. Now, in terms of Auth, what next? Well, the Auth 2.0 spec was published in 2012 when the iPhone 5 and IE9 were trendy. So it's getting on a bit, and it's composed of more than 15 RFCs with lots of optional parts. This has been dubbed its biggest failure because it's got RFCs all over the place. It's also been dubbed its biggest success because it's allowed a lot of innovation over the past few years. But overall, it started with 4 different flows. It's got a 5th one added. It's got 2 of them deprecated, and it's got extension. So it's a bit messy. And there are a number of initiatives at the moment. One is Auth 2.1. That's and Auth 2.1 is simply an initiative to remove the deprecated bit, add the new bits, and consolidate everything into a single spec. So in theory, it should be completely backward with Auth 2 when it's released. And then you've got Auth 3.0, which is designed to be a complete rewrite, learning from Auth 1 and Auth 2. But like every single rewrite, especially when you're talking about open standards, it's not a quick process. So it's not going to be available anytime soon. And in addition to that, you also have a set of experimental and draft specs that have not quite made it into the standard, but are nearly there. A lot of them are quite technical, but one that I find very interesting is the incremental authorization that has been pushed by Google and is available with the Google OpenID Connect implementation. It's basically the concept that you don't need to ask for everything on the first query. So if you use Google as an OpenID Connect provider, what you can do is just log into Google with a basic OpenID scope that gives you user identity. But say if you want to use Google Sheets after that, then you can ask for the Google Sheets authorization as an additional authorization from what you already have, without asking for everything back again. So that's the principle behind it. And there we have it. That's a whistle-stop tour of Auth 2 and OpenID Connect, and it's a lot more than what I originally thought I would actually write, but that's where we are. So I'm happy to take questions.
Hello. I saw on one of your slides you mentioned PKC, but I don't actually know what that is. If you know, what is it?
Right, so I'll go back to that slide. Well, it's here. PKC, pronounced Pixie. It's basically, and I've got an explanation of the acronym somewhere. Let's go back up. Yes, proof key for code exchange. Basically, what this is the fact that a single page application or a mobile app works in an environment which is not necessarily secure. So you can't trust it to be able to securely store the client secrets when you get to the token endpoint. So it's a process to be able to give the application, the instance of the application that you're using at the moment, a one-off access code that only that implementation of the application knows about. So it's an extension, it's an extra code exchange process that that happens between the authorization server and the application. And that's one of the reasons why I would say use when you build a client for Auth 2, use an existing library, at least at first, that does this for you. So for example, in React Native, the App Auth library, which ships with React Native, does that on its own. You don't have to deal with it.
Thank you.
Can I ask why you need a separate server from your resource?
You don't need the separate server, yet you can have a separate server. But so basically the design separates the two concepts so that the authorization server is separated from the resource server. What this means is that you can share your authorization server between multiple resource servers. So that's one way to bring a single sign-on to a complex system. But in practice, you could run both on the same server if you wanted to. In practice as well, building an authorization server is hard, especially when you deal with password and all that sort of things. So personally, I'd rather use one that I know works than trying to build my own.
Oh yeah, I'm with you on that.
Great. So that's going to have to be our last question for this talk. But yeah, thank you so much. This was really useful, and personally, I found it really helpful. And I hope everyone did too as well.